Pairs of lines and transversal. You are already familiar with the concept of lines and angles from the previous topics. Here are some close-ups of things you have seen before. Can you recognize them? I'll play you some music while you figure out. I hope you got them all correct. They are the railway track, lines in a book, rows of students, and the tracks of a car tire. Would you believe me if I said that these lines will never meet? How can we find out if these lines are actually parallel? In this topic, you shall learn about pairs of lines, a transversal, angles made by a transversal, with a pair of lines and the relation between the angles made by a transversal with two parallel lines in the same plane. A transversal is a line that intersects two or more lines in a plane at distinct points. Look at the illustration. Here two lines, L and M, are intersected by another line, N, at points A and B. Therefore, line N is the transversal line. Similarly, line L is the transversal to lines P, Q, and R, intersecting at points A, B, and C respectively. A transversal is a line that cuts two or more lines at distinct points on the line. Example: in the first figure, the lines intersect and do not cut each other. There is no transversal here. In figure 2, the line P cuts line L, M, and N. So P is a transversal. When two or more lines are intersected by a transversal at distinct points, there are 8 angles formed at the point of intersection. These pairs of angles are exterior angles, interior angles, corresponding angles, alternate angles. Was that too confusing? The angles thus formed are related to each other. You will look at each of them subsequently. When two lines are intersected by a transversal in the same plane, then the angles formed between the two lines and the transversal at the points of intersection are called interior angles, and angles formed outside are called exterior angles. Look at the illustration. The angles 1, 2, 7, and 8 are exterior angles, and angles 3, 4, 5, and 6 are interior angles. If a transversal intersects two lines lying in the same plane, then a pair of angles formed is said to be corresponding when both angles of the pair lie on the same side of the transversal, like angles 1 and 5, angles 2 and 6, angles 3 and 7, and angles 4 and 8. If a transversal intersects two lines that lie in the same plane, then a pair of angles is said to be alternate interior angles if both the angles in the pair are interior angles. The angles lie on the opposite sides of the transversal. These angles do not form a linear pair. Do you observe anything in common in the following list? Edges of a ruler, sides of doors, railway tracks, power cables running from pole to pole. You will notice that all these have a parallel property in common. You will recall that two lines in a plane either intersect each other or they do not intersect each other. Lines that do not intersect at all are called parallel lines. Therefore, two distinct lines lying in the same plane are said to be parallel if they do not intersect each other at any point. For example, edges of a ruler, sides of doors, railway tracks, power cables from pole to pole, etc. The perpendicular distance between two parallel lines remains the same throughout the length. However, the distance between two intersecting lines is zero at the point of intersection. Let's look at the properties of angles formed by two parallel lines and a transversal. If two parallel lines are intersected by a transversal, then the angles of each pair of corresponding angles formed are equal. The angles of each pair of alternate interior angles are equal. The sum of the interior angles on the same side of the transversal is 180 degrees, or the interior angles on the same side of the transversal are supplementary. If any one of the above three conditions are met, then the lines are parallel. Deepa and Seema are friends. Deepa says she has drawn all the pairs of lines L and M given below are parallel. But Seema argues that they are all not parallel. Could you help Seema to find out which of the pairs are parallel and which are not? So click on to yes to say that they are parallel and click on no to say they are not parallel. Given here are parallel lines and a transversal. You can see one angle highlighted. Click on the other corresponding angle. Given here are parallel lines and a transversal. You can see one angle highlighted. Click on an alternate angle. State in which of the following figures N is not a transversal. Look at the highlighted figure and click on the appropriate statement. In the following figure, L is parallel to M. P and Q are the two transversals. Calculate the degree measures of the angles X, Y, and Z. Key in the correct answer in the space provided. Given here is a pair of parallel lines. The angles have been marked A, B, C, D, E, F, and G. Click on the option that expresses the relationship between these angles. Hari says L and M are parallel lines. Could you help him find out the value of x? Click on the right answer.